Our next lecture is on section 1.4, Other Effective Sampling Methods. Our objectives in this section are to look at three different types of samples: a stratified sample, a systematic sample, and a cluster sample. First, we look at a stratified sample. Remember, the goal of sampling is to obtain as much information as possible to answer our question about a population at the least cost. Remember, we're using the word cost in a general sense. Cost includes any monetary outlays, time, and other resources like our staff or surveying people, time, money, salaries, etc., and even tools creating them. With this goal in mind, it may be advantageous to use sampling techniques other than simple random sampling. One of those is a stratified sample. A stratified sample is obtained by separating the population into non-overlapping groups called strata, and then obtaining a simple random sample from each strata. Okay, this is a very common thing. The individuals within each stratum should be homogeneous, and that just means that they are alike in some way. That pertains to what we're trying to find out. Some examples might be the age. We might want to see the age groups in a community or in a school and then put them into groups to ask them the same thing to see if age impacts the results of our survey. We see this also with income, with politics, etc. We might want to ask people from different political parties the same question to see if there are differences about that. I put etc. here because there could be tons of different ways to stratify something. Now, what's key in here is also that they have to be broken down into non-overlapping groups. So if we go back to age, when you're doing grouping, you'd say, like, you couldn't say 10 to 12 and 12 to 14 because you've used 12 in two different groups. So you might, if the age group starts at 10, you might say 10 to 15, 16 to 20, etc. Income gets a little more complicated. So if I say 0 to 25,000, then I have to say, if I'm going to use just dollars, let's say, then I have to say $25,001 up to 30,000, $30,001 up, etc. So the non-overlapping is really key here, and this is sometimes a place where we get mixed up in our surveys if we don't do them correctly or we miss something. Like, for example, let's say I did income again, and I did 20 to 30,000, and then I did 35,000, etc. So I've missed the whole category between $30,001 all the way up to 35,000. Okay, so it's an important thing. So let's look at an example of how this might be used. And this is a great example from your text. The president of DePaul University wants to conduct a study to determine the community's opinion regarding campus safety. So what the president does is divides the DePaul community into three groups: students who are residents who live on campus, non-resident students who commute every day, and staff, which includes faculty, so that he can obtain a stratified sample. What he's trying to do is figure out, what does each of those three groups think about safety, and what are their maybe individual concerns as compared to each other. Suppose there are 6,204 resident students. There's 13,304 commuting or students who don't live on campus, and there's 2,401 staff, for a total of 21,909 individuals in the total population. You'll notice I've put in parentheses the percentage, and that's simply, for example, 6,204 resident students that live on campus, divided by 21,909 gives me 0.28, or 28%. And so we get the percentage of each stratum here. When we're talking about residents, non-residents is 61%, and staff is 11%. Now, sometimes studies don't care about the percentage, and they might want an equal perspective of all three stratums. So they might just say, okay, I want a sample of, let's say, 90, so I'm going to take 30 from each group. Sometimes I want my sample to be representative of the population, and that's what actually happens here, that the president wants to have a sample that take the survey that's based on the population, that's weighted by the population size. So the sample is also going to have 28% resident students, and 61% of the people on the survey will be commuters, and 11% will be the staff and faculty. They decide that they're going to use a sample size of 100, and when you're basing it on percentages, this makes it really simple, because this just indicates that I'm going to use the same number as percent, right? Because that's what percent is actually based on, per 100. Percent literally means per 100 in French, and that's where that name comes from. So if I have 100 people in the sample, I'm going to have 28 residents, 61 non-residents, and 11 staff. So it makes the breakdown easy. If I did 200, I would just multiply these by 2. You know, it's not hard to do percents. If I wanted a population, a sample of 5, let me just change that again, a sample of 150, then I would take 0.28 times 150 to get the number of residents, and 0.61 times 150, etc. So that's not a difficult thing to do. Once you have those groups, we would get a simple random sample from each group by using a random number generator like in a prior section. This is if we're actually going to take a smaller number of people to survey. Like if we only really want to survey 5 in each group, then we would do something like a random sample from there. Okay, but in this case, you could easily survey all those people and keep the results separate, etc. But in this specific study, they actually didn't want to interview 28, 61, and 11. It looks like they wanted to interview the same number from each group, but this is how they broke it down to do a random sample. They first identified a sample of this many people and then did the random sample. It seems like it's actually a little bit of overkill in my mind. Why wouldn't you just go ahead and, 100 surveys is not a lot of surveys, especially when you're talking about a population of 21,000. But it's an illustration nonetheless. An advantage of the stratified sampling that we just looked at over simple random sampling is that the researcher can determine characteristics within each stratum, and then this allows an analysis to be performed on each stratum to see if any significant differences among them exist, and this could be really insightful to any kind of study. In simple random sampling and stratified sampling, both require a frame. You remember that frame is just a list of all the individuals in a population being studied. Therefore, these sampling techniques both require some preliminary work before obtaining the sample. A sampling technique that does not require a frame is systematic sampling. And systematic sample is obtained by selecting every kth individual from the population. The first individual selected is a random number between 1 and k, and then you would just select, let's say we wanted every 10th individual. So we'd pick a random number between 1 and 10. I think I just said every 10th individual. Let's say we do a random generator, we get 7. And then we would pick every 10th individual after that. So 7, 17, 27, 37, etc. And this gives us a systematic sample without having to create a frame. So let's look at an example how a systematic sample might work. The manager of Kroger Food Stores wants to measure the satisfaction of the store's customers. To do that, he's going to design a sampling technique that can be used to obtain a sample of 40 customers. The manager decides to obtain a systematic sample by surveying every 7th customer. He randomly determines a number between 1 and 7, the starting point, say 5. He then surveys the 5th customer exiting the store, and then every 7th customer thereafter until he has a sample of 40 customers. So this survey will include 5 plus 7 is 12, 12 plus 7 is 19, etc., until he gets to that 40th customer, which will be the 278th customer. Now, what might be a problem here? Can you think of what a problem might be? Well, if we pick this sampling number, like in this case 7th customer, here it could be either too small or too big. In this case, it might be too small. Because we're going to need 278 customers. Well, I don't know how many customers go into Kroger in a day, but if this is too small and we start in the morning, we might only interview or survey customers that come in the morning time, and so we miss the afternoon or evening customers. If we pick a number that's too big, so instead of surveying every 7th customer, we decide to survey every 50th customer, well, we might not have enough customers then. We may not get all of the responses that we want for the day. Okay? Because if we do every 50th customer and we want 40 surveys, 50 times 40 is 2,000, and maybe we don't have 2,000 in a day. So this is the problem here. But there's an easy way to figure out, which customer or which person or group or sample do we survey. So how do we figure out the right sample size? Okay, if we know the population size, in this we're naming this uppercase N. In the last example, that would be the average number of customers that come into a store, into a Kroger store. So kind of the total, maybe we do the average number on a Thursday or whatever day we're sampling, etc. But we're trying to figure out the population size, which in our last survey was the number of people coming into a Kroger store in a day. And then we determine the sample size. How many people do we want to actually survey? So maybe it's 50, maybe it's 30, etc. So what we would do then is we would compute the population size, uppercase N, divided by the sample size, lowercase n, and then round down to the nearest integer. These are our counting numbers. Remember, 1, 2, 3, 4, whole numbers, etc. And then this is our k. We're going to label this k. And so this is the number of, the number of individuals that the next individual we're going to survey is k units later. So again, just like we've seen, first we're going to pick a random number between 1 and k. So let's just say we get 20 as k. So we're going to pick a random number between 1 and 20. Let's say we get 15. And we're going to call this number p. This is our starting point for our survey. And then, of course, if we pick 15 and k was 20, then the next person we would get would be 15 plus 20, which is 35, plus 20 is 55. So we'd be interviewing the 15th customer, then the 35th customer that comes out, then the 55th, etc. And so this is just the general formula for that. So again, we first survey the random number or the random pick between 1 and k, and then we just keep adding k to it until we get to the very last person, which is our sample size minus 1 times k, because we picked a random number between 1 and k to begin with. So this is a way to make sure that you are sampling across the full population. In the last example, we wanted to make sure we got early and late customers, that we were there for the whole day, because those type of customers might have different opinions about something, etc. As we saw in the last example, because systematic sampling does not require a frame, it typically provides more information for a given cost than does simple random sampling. In addition, systematic sampling is easier to employ So there's less likelihood of interviewer error occurring, such as selecting the wrong individual to be surveyed or some kind of unconscious bias, etc. You're just literally picking the seventh next person or something. A fourth sampling method is called cluster sampling. Like the previous three sampling methods, this method has benefits under certain circumstances. A cluster sample is obtained by selecting all individuals within a randomly selected collection or group of individuals. Let's look at a simple example to kind of understand this a little more clearly. Suppose a school administrator wants to learn the characteristics of students enrolled in online classes. Rather than obtaining a simple random sample based on the frame of all students enrolled in online classes, the administrator could treat each class as a cluster and then obtain a simple random sample of these clusters. So let's say he has 100 online classes. So you have 100 clusters, and then he could randomly pick 5 clusters, again, random numbers between 1 and 100, pick 5 of those numbers, and then interview all of the students in that class. This reduces the number of classes that get surveyed and makes it a different kind of sample that's easier to find. So let's look at our next example, obtaining a cluster sample. A sociologist wants to gather data regarding household income within the city of Boston. Obtain a sample using cluster sampling. Suppose there are 10,493 city blocks in Boston. First, the sociologist must number the blocks from 1 to 10,493. Here we're going to use each block as a cluster. Suppose the sociologist has enough time and money to survey 20 clusters, or in this case 20 city blocks, because each block is going to be one of our clusters. The sociologist should obtain a simple random sample of 20 numbers between 1 and 10,493 and then survey all the households from the clusters selected. This is a good choice in this example because it reduces the travel time to households that is likely to occur with both simple random sampling or if we did stratified sampling. Because we're picking one whole city block, you get to survey everyone in there, and this is talking about the travel time. In addition, there's no need to obtain a frame of all the households, which is a lot larger than the 10,400, etc., with cluster sampling, because we are only needing a frame for all of the blocks, which includes a large number of households, I would assume, in each block. Now be careful here, because sometimes we get stratified and cluster samples confused. In a stratified sample, we divide the population into 2 or more homogeneous similar groups, then we attain a simple random sample from each group. In a cluster sample, we divide the population into groups, attain a simple random sampling of some of the groups, not by categories, etc., and then survey all of the individuals in the selected groups. Okay, so be careful with that and make sure that you understand the difference between stratified and cluster samples. When we're doing clustering samples, or cluster sampling, here's some questions you want to ask yourself. How do I cluster the population? How many clusters do I sample? And how many individuals should be in each cluster? And this is both a financial question, but it's also a kind of a content or categorization type of questions as well. So first we need to determine whether the individuals within the proposed cluster are homogeneous, which means they're very similar, or heterogeneous, which means they're not alike. In example 3, city blocks tend to have similar households, so we would expect the incomes to be similar. Survey responses from houses on the same block then were likely to be similar. This results in duplicate information. We conclude that if the clusters have homogeneous individuals, it is better to have more clusters with fewer individuals in each cluster. We don't need to do the whole block per se if everyone in the block has a similar viewpoint. But what if the cluster is heterogeneous? Under this circumstance, the heterogeneity of the cluster likely resembles the heterogeneity of the population. In other words, each cluster is a scaled-down representation of the overall population. For example, a quality control manager might use shipping boxes that contain 100 light bulbs as a cluster, since the rate of defects within the cluster would resemble the rate of defects in the population, assuming the bulbs are randomly placed in the box. Thus, when each cluster is heterogeneous, fewer clusters with more individuals in each are appropriate. In the 4 sampling techniques that we've looked at in this section and the previous one, the individuals were selected randomly. Inappropriate sampling methods are those in which the individuals are not randomly selected. Have you ever watched a talk show where the host asks listener to reply to a poll like through online or using your phone like on the evening news? This is a non-scientific data collection method, so the results of any analysis are suspect because the data was obtained using a convenience sample. A convenience sample is one in which the individuals in the sample are easily obtained. Typically on those TV news surveys, you have people that are responding that are very interested in the topic, which may not be representative of the entire population. So be careful. Any studies that use convenience sampling, the results should be looked upon with extreme skepticism. The most popular of the many types of convenience samples are those in which the individuals in the sample are self-selected. The individuals pick themselves and decide to participate. These are also called voluntary response samples. In practice, most large-scale surveys obtain samples using a combination of the techniques just presented. As an example of multi-stage sampling, consider Nielsen Media Research. Nielsen randomly selects households and monitors the television programs these households are watching through a people meter. The meter is an electronic box placed on each TV within the household. The people meter then measures what program is being watched and who is watching it. Nielsen selects the households with the use of a two-stage sampling process. First, using census data, Nielsen divides the country into geographic areas, strata. The strata are typically city blocks in urban areas and geographic regions in rural areas. About 6,000 strata are then randomly selected. Nielsen sends representatives to the selected strata and lists the households within the strata. The households are then randomly selected through a simple random sample. Nielsen sells the information obtained to television stations and companies, and these results are used to help determine prices for commercials. So here's like a great diagram of all the different types of sampling techniques. We can see the simple random sampling from population to sample. We can see strata sampling, systematic sampling, and then cluster sampling. I love this image because it helps me kind of remember what each kind of sampling does.